No, World War II combat engineer did not carry all of this at once. He carried his rifle and fighting kit while the squad divided the mine detector, explosives, wire cutters, Bangalore torpedoes, and bazooka. That is what most loadout videos get wrong. Here is the real equipment American engineers carried to clear mines, destroy obstacles, and open the way under fire. We have the M1 steel helmet. It used a steel outer shell with a separate adjustable liner inside, so the shell took fragments while the liner made it wearable for more than 5 minutes. The World War II helmet weighed about 3 pounds with liner and chin strap, and it entered United States service in 1941. For a combat engineer working around shell bursts, mines, wire, and flying debris, this was not decoration. It was the difference between a bad day and a very short one. Next, we have the M1943 field jacket. It was a longer olive drab field jacket made for layering, with 4 front pockets and a looser cut than the earlier short field jacket. It began replacing older patterns after 1943, although frontline issue depended on theater, supply, and the Army's usual relationship with perfect timing. For engineers, the payoff was practical: better weather protection while digging, wiring charges, clearing roads, and standing in mud pretending this was still a profession. Let us continue with the M1 Garand rifle. It was a gas-operated semi-automatic rifle with a rotating bolt and an 8-round on-block clip. It fired the .30-06 Springfield cartridge, weighed about 9.5 pounds, and let a trained soldier fire far faster than a bolt-action rifleman. Combat engineers were not just construction workers with helmets. When the breach started, they were close enough to the enemy to need a real rifle. Moving on to the cartridge belt with 8-round clips. The belt used canvas pockets to carry Garand ammunition clips across the waist, keeping weight spread and reloads reachable. A full 10-pocket Garand belt held 10 clips, which meant 80 rounds of .30-06 ammunition ready for the rifle. That mattered because engineers often worked exposed at obstacles, and politely asking the enemy to wait while you cleared wire was not a recognized tactic. We have the M1 bayonet and scabbard. The M1 bayonet used a 10-inch blade and fit the M1 Garand, with the M7 scabbard carrying it on the belt. It was adopted during the war as a shorter, handier replacement for the earlier 16-inch bayonet. Its combat value was not just dramatic last stance. It cut, pried lightly, probed, and reminded everyone that a rifle could become a spear if the day had truly collapsed. Next, we have the Mark II fragmentation grenades. The Mark II used a cast-iron body with deep grooves and a delay fuse that usually gave around 4 to 5 seconds after release. By later World War II production, many were filled with trinitrotoluene and weighed about 1 1/3 pounds. For engineers clearing bunkers, trenches, roadblocks, and buildings, the grenade gave immediate violence in a small package. Subtle? No. Useful? Unfortunately, yes.
Let us continue with the canteen, cup, and cover. The standard canteen held 1 quart, the metal cup nested around it, and the canvas cover helped carry it on the belt or pack. 1 quart did not make a man comfortable during road clearing or mine work, but it kept him functioning long enough to complain accurately. For a combat engineer, water was not a luxury item. Digging, lifting, crawling, and carrying explosives burned through men faster than most planning tables like to admit. Moving on to the first aid packet and pouch. This was a small belt-carried dressing packet, often associated with the Carlisle-style bandage in a protective container. It was meant for immediate bleeding control before a medic could reach the wounded man. For combat engineers, that mattered because mines and demolition work produced exactly the kind of injuries nobody wanted to describe twice. We have the folding entrenching tool. The M1943-style folding tool used a shovel blade that could fold for carrying and lock open for digging. It rode in a carrier and gave one man a compact way to scrape cover, dig firing positions, and move soil around mines or obstacles. It was not glamorous, neither is surviving artillery, which is why soldiers kept digging. Next, we have the M1928 Haversack or Field Pack. The M1928 Haversack was a web pack system that carried rations, spare clothing, shelter items, mess gear, and whatever else the Army believed a spine could tolerate. By late war, field packs and other carrying arrangements appeared depending on issue, unit, and mission. For combat engineers, the pack was where personal equipment met specialist burden. Naturally, the solution was to carry both. Famous combat engineer equipment. Let us continue with the SCR-625 mine detector. It used a search coil in a round wooden disc with an amplifier, batteries, resonator, and earphones that warned the operator when metal was detected. The full detector set weighed about 7.5 pounds and could find many metallic mines buried several inches under the surface. Its real payoff was speed with survival. Not fast, just faster than finding mines with a boot, which is a very low bar, but an important one. Moving on to the mine probe. A mine probe was not always a special fancy tool. Engineers often used a bayonet or another pointed tool to feel through soil carefully. The point was to locate a buried mine without putting full pressure on the fuse area. This was the old-fashioned partner to the mine detector. One machine hummed in your ear, then one nervous man checked whether the earth was trying to kill him. We have heavy engineer wire cutters. They used long handles and hardened jaws to bite through barbed wire, fencing, and obstacle wire. Combat engineers use them around wire belts, roadblocks, beach obstacles, and minefield lanes where wire and mines were often combined. The payoff was simple. A silent cut could open a gap without using explosives. Quiet was rare, so engineers tried not to waste it.
Next, we have the Pigmatic. It combined a pointed pick on one side with an adze-like cutting blade on the other, mounted on a wooden handle. Engineer squads used tools like this to break hard ground, trench around obstacles, expose buried objects, and prepare demolition work. It was slow, heavy, and completely necessary. War has a funny way of turning medieval farm labor into modern combat engineering. Let us continue with the axe or hatchet. This was a chopping tool for timber, brush, stakes, poles, crates, and improvised fieldwork. Engineers used axes and hatchets to clear lanes, cut materials, build revetments, and remove wooden obstacles. The tactical payoff was flexibility. A unit that could cut wood, shape materials, and clear paths did not have to wait for perfect conditions, which were not scheduled until after the war. Moving on to the sledgehammer. The sledgehammer was a heavy, steel-headed striking tool on a long wooden handle. Engineer work used it for driving stakes, breaking masonry, smashing fittings, and forcing stubborn hardware during demolition preparation. It was not subtle engineering. It was engineering after the object refused to cooperate. We have trinitrotoluene demolition blocks. These were pre-packaged high-explosive blocks made for military demolition work, commonly seen in half-pound and one-pound forms. They could be used against wire supports, roadblocks, bridge parts, vehicles, and fixed obstacles when properly prepared by trained engineers. The payoff was controlled destructive power. Infantry could shoot an obstacle, engineers could remove the obstacle, and everyone's illusions about neat battlefield geometry. Next, we have electric and non-electric blasting caps. A blasting cap was the small initiator that started the explosive train. Electric caps used current, while non-electric caps used a flame-based initiation system. They were small, sensitive, and treated separately from main charges for obvious reasons. For engineers, caps turned inert explosive into a working demolition system. Without them, trinitrotoluene blocks were mostly angry-looking paperweights. Let us continue with time fuse and fuse lighter. Time fuse used a burning internal train to create a delay, and the fuse lighter gave a more reliable ignition than matches in bad weather. This allowed engineers to start a non-electric demolition with enough delay to reach cover. The payoff was independence from wires and batteries. The drawback was that delay work made every... Moving on to detonating cord. Detonating cord was a flexible cord with a high explosive core made to transmit detonation from one charge to another. Engineers used it to link charges, fire multiple points, and spread explosive effect across a target. Its combat value was synchronization. One blast could do the work of several separate charges, which is helpful when the enemy is not waiting patiently for a second attempt. We have the blasting machine with firing wire.
The blasting machine was a small hand-operated generator used to send current through firing wire to electric blasting caps. United States engineered demolition equipment included machines with different cap capacities, including 10 cap, 30 cap, 50 cap, and larger types. The payoff was distance and control. The engineer could fire the charge from cover, which is generally better than standing beside the bridge while physics makes its point. Next, we have the Bangalore torpedo. The United States M1A1 Bangalore torpedo used connectable explosive-filled metal tubes that could be pushed through wire obstacles from a safer distance. Each section was 5 feet long, a little over 2 inches in diameter, and weighed about 13 pounds. A crate held 10 sections with sleeves and weighed 176 pounds. Its payoff was brutal and direct. It opened paths through barbed wire and obstacles. It did not make engineers safe. It made them slightly less doomed at the wire. Let us continue with anti-tank mines. United States anti-tank mines such as the M1 and M1A1 used a steel circular body with a pressure spider over the fuse area. The M1 type mine weighed about 10.5 pounds and carried roughly 6 pounds of trinitrotoluene. Engineers used anti-tank mines to block roads, protect flanks, and shape enemy vehicle movement. The best minefield was not just deadly, it made enemy drivers choose a worse road. Moving on to minefield markers and marking tape. These were simple visual control tools. Tape, signs, stakes, flags, or improvised markers used to identify lanes, edges, and cleared paths. In a minefield, a safe lane that nobody can see is only slightly better than no safe lane at all. The payoff was friendly survival. Engineers marked the routes so infantry, vehicles, and follow-up troops did not proudly walk back into the problem that had just been solved. Specialist weapon. We have the M9 2.36-inch bazooka and rockets. The M9 was a shoulder-fired rocket launcher with an open tube design, improved ignition, and a two-piece tube that made transport easier than the earlier models. It fired 2.36-inch rockets, such as the M6A3, which weighed about 3.5 pounds and used a shaped charge warhead against armor. For combat engineers, the bazooka was useful against vehicles, strong points, and obstacles. It was not a magic tank eraser, despite what recruiting optimism probably wanted, but it gave small teams a real anti-tank punch. That was the combat engineer loadout. Rifle first, tools second, explosives everywhere, and comfort nowhere. The important thing is that this was not one superhero carrying a full engineer depot on his back. It was a squad load, split between men according to mission, terrain, and how much misery the job required. The United States Army combat engineer had to fight like infantry, dig like labor, think like a demolition man, and move like someone being shot at while carrying equipment designed by a committee. So when you see a combat engineer in World War II, do not picture just a man with a shovel. Picture the man sent forward to find the mines, cut the wire, blow the gap, mark the lane, and then keep fighting through it, which is a very efficient way to make one job out of 4 bad ones.